Out. Okay, so let's talk about this problem. I think she had some really great ideas, um, but let's just talk as a class. Like what were some of our approaches? What did this problem remind us of? Thoughts about it? Floor is open.
I think for me, like I was setting up the count, but then I got confused with how to then use the count to to compare it to a palindrome. So I was stuck on that part.
Okay, yeah. So you recognize that you could have a good, like you could definitely use a count somehow, but after making the count, you're not entirely sure how to actually use it to
Yeah.
determine. Okay, yeah, that's fair. Any other thoughts about this problem?
Yeah, I'm in the same boat. I tried to use. I'm like trying to figure out what to do with the count because at first all I did was like a simple reverse, but I sort
Simple
of
what?
like I just did like a.
Couldn't hear you again. Sorry.
I definitely caught it, but I think he said reverse.
I
Okay.
did something now. Am I clear now or no?
Yes.
Okay, cool. So I at first I didn't really get the question. So at first I did like I just reversed the string and I checked to see if it was a palindrome. But then when Ashia mentioned the count, I started utilizing the count and I don't exactly know what to do past the count. So I'm trying to figure that out as well.
Cool. So let me ask you all this. A lot of us seems to be using a count. I think that's great. I think that's definitely the direction we're going to end up going. Can anybody just tell me like what, because we want to be able to identify multiple ways of solving this. That doesn't mean we should solve it multiple ways, but just the idea of identifying multiple solutions. Can anybody else tell me a different solution? Without worrying about, if you weren't worried at all about time complexity or anything like that, what's kind of like the brute force solution to this problem?
Maybe just like iterate through the string and yeah, like each step of the iteration, you could check to see, you could somehow check to see whether or not like that's a palindrome, like at that step, somehow. I don't really know how that would
Okay.
go, but because if you like do some kind of like, if you use some kind of like method where you like flip like the first index to like the second index and then you check, like all the way to like the length of the string, like the end of the string. And if it comes back true at each step, then it could be a palindrome no matter how, like no matter how it's flipped or what order it's in, because that can sort of that iteration can sort of like give an example of many different ways it could be flipped. But if it could be reversed through all those ways and be a palindrome, then it's got to be a palindrome. It could be a palindrome through and through. But I feel like that would be a really long way of doing it. But I think the idea.
Marvin, I think you're talking about like a sort, like sorting the string. Because like if you're sorting the string, if it's palindrome, then you mean if sorting that by like letter A or letter B, the first like two letters should be the same. The second two letters should be the same. The second two index should be the same.
But what about if, like, here, I'll write it in the chat, but what if it was just like AAAB? It changed it to AAH, but is that a palindrome?
That's not a palindrome.
Case insensitive. Is that a permutation of a palindrome?
I don't think it will be case sensitive. Everything should be like a lowercase or uppercase.
Yeah, so if we're case insensitive, so if we're not worrying about case.
I would say it is a palindrome because you have 4 A's and that's an even number. So you could place the H right in the middle and it would be AAHAA.
Exactly. Good. Nice. Right. So that still is a permutation of a palindrome. So I don't know if sorting would necessarily help. What can you like really brute force? Like, what could you do? You're all gonna go like this after.
You could physically place, you could move the letters if they have a double, you could move the letters to the opposite ends, like to their given opposite ends. Maybe like a insert.
Maybe I think that's still not exactly brute force. If
Okay.
we think back to our time complexities, what was something that took factorial time? What's the go-to example? So if we seem to be stuck. I want to share my screen. I'm trying to do it through this other program. Okay, it's this one that I'm sharing.
Oh, and the exclamation mark.
Right. Oh, you can't see my screen still, can you? Hang on.
No.
Why can I not get this? Maybe I have to go. Hang on. I want to get this. Add screen share. There we go. Okay. Now we've got, you can see my screen, right? This screen? Can you see my screen?
Yes.
Yeah.
Does it look like this search bar?
It looks like you doubled up.
Yeah, there's multiple cores.
Oh.
Like we can see your Zoom.
Oh, okay. Let me try this screen. Sorry. Okay. This screen you can see.
Yep.
Yes.
All right. Cool. And you can still see me.
Yes.
Cool. Okay. So if we look at like time complexities, right? Cheat sheet. Let's see if they'll actually give us the common examples. So I really want So we have, all right, this one is our factorial time. And so what actually takes factorial time? I guess it's not written here, but in previous times, we've talked about permutations, right? Permutations takes factorial time. So if we're talking about a problem that is asking if there's a permutation of a palindrome, right? I mean, the brute force solution is to make every permutation of the string and then go through all of those string permutations and determine whether or not it's a palindrome.
Wait, like physically write out each version of the
To code it.
Right.
It would still take time, right? I mean, coding permutations is a little bit of a tricky method, but in some languages it's already built. It's actually built. Like Ruby, you can just call .permutations and it would permeate. It might just be an array method, but we could split the string into the array, and checking to see if something is a palindrome in itself is fairly straightforward, right? You just start at the end and the beginning, and you iterate through and check if the letters are the same. Maybe we'll get that one up tomorrow. But so that's really the brute force solution, right? If we're just thinking like we don't care about time complexity, we just want to check if this is a permutation, we could just make all the permutations. The time would be n factorial. So that wouldn't be great. But it's important to be able to identify brute force solutions as well. It's great that everybody jumped to the object. That's actually the slightly less obvious solution. But I'm happy that everybody did get to that. Regardless. So what are some good clarifying questions that we could ask if we were given this problem?
If the string is a single word or a single sentence.
Or a sentence. So yeah, so is this okay, so Henry says, is the string a single word or a sentence? So what's that what question is that really getting at? What are you really asking for there?
I think he means, do we have a space in between the letters?
Okay, so are there spaces in the string, and how should those be handled? Okay. What else? Those are good. Thanks, Henry. Thanks, Kong. What are other questions we could ask?
Case sensitive. Yeah, case sensitive.
Awesome. Yeah. Should this be case sensitive? Excellent, right? Because should A be the same as A be A? Right? That's up to your interviewer. What else? By the way, the writing is clear on yours, right? On everyone's screen, because like, I think my Zoom is flipped, so I see the image is flipped. So
I think I would say it's not that clear. It's like low quality, you know, like bootleg version of Zoom.
can you see it better now, Kong?
Yeah.
It's a little bigger, but it's not like crystal clear.
Okay. Is it readable?
Yeah, it's readable.
Yeah, it's
Okay.
very,
But but the words go from left to right.
Yeah.
Okay, great. So on the way, okay. So mine, the way I have my settings, it's flipped. So the words go from right to left. Okay, we're good. Okay, what other questions could we ask if we were presented this problem?
do we have an empty string?
Okay, sure. So what should an empty string return?
Are time complexity questions good clarifying questions? Like how fast? Like I guess like I don't know how to word it, but like how fast would you want this thing to run? Like would you want it to run like to give like an idea as to like what sort of methods we could be using or what sort of approach we could be having.
I think that's definitely something that you can ask. I think it's slightly expected to be able to come up with that yourself to try to recognize the bottlenecks. Like, we know that we could do this. The slowest situation this could be is permutations, which is factorial. And so we can think of if there's a way to make it faster, like to only go through everything once. Because we know it can't be constant, right? Because that's just looking up things, basic math. That's like all constant time. But like, we know we're going to have to at least iterate through it. So we know in the dream it would be n.
Yeah.
So like, and yeah, it's something that you should feel okay discussing with the interviewer, but you should also be bringing things to the table with the times and not just saying like, what time complexity should this run at? Because they'll probably ask what depends on how you're going to implement the function. These clarifying questions, you want to more focus on edge cases and like different types of inputs and outputs that we should be expecting. So like another one would be like, should I worry about punctuation? Should the string, does like, should I be concerned, you know, about other languages? Maybe they're putting in Mandarin, right? Like, who knows? Like, how does that change anything? Or different symbols? Are these just ASCII symbols? Or should I be defensive? Do I have to worry about somebody putting in a number or something?
I was thinking that, like, is this question not limited to just strings, but also numbers?
Sure. Yeah, how defensive make this. Because if it's not always going to be given a string, we have to check to make sure this is a string. Otherwise, we need to be throwing an error, right? You can do something like that with like type of, if you remember from unit 1, let's see, we can say like, what is this? It's like, hello, type of string? No. Anybody remember? It's been a while.
I thought it was type of and parenthesis, whatever you input on that parenthesis.
Like this?
Yes.
Yes, thank you. Right? So we would just be doing like type of string equal to string, right? This is a check. So if this, go ahead and continue. Or like if this is not equal to string, then we could be throwing an error, you know. Input must be string. Right, so these are things to think about. These are things to ask about just to make sure that you're only getting good information. So these are all good questions. If you ask all these questions, you're on a good start. Right, we also should be talking about the different inputs in creating different outputs. So I created these during the break. I shared them in the chat a little earlier, but right, this is just race car jumbled up. So we got our true. This is ABBA jumbled up. And this is a non-palindrome. So let's think about this as part of our approach. Let's write some rules. So like rules being like what makes something a palindrome? And I think Ashia has already said some of them. So let's revisit those.
The length has to be the same. I guess like in reverse. I think that was one of the things.
What do you mean length has to be the same?
Well, like the string coming in. Well, it's not going to be manipulated anyway, so I guess it's like a silly rule. I'm trying to think.
Well, what makes something a palindrome? So like, let's start looking at this. Is this a palindrome? What?
I guess.
Nah.
So people say no? Can it be read the same forward and backward?
I guess technically, yeah.
Well, you put 8 in a space, right?
Oh, ignore spaces. I was.
Oh, my bad. I'm being too.
That's fine.
But yeah, I mean, now it is.
So that's a palindrome. Okay. How about a?
Yes, still.
Okay. So if I want to add a B, where do I put the B?
Middle.
In the middle.
Middle.
Okay.
Anywhere.
So now we have a B, and we're still in a palindrome. If I want to add another B, where would it go, or how would it work?
Middle.
Next to the B in the middle.
So how come?
Because you
This
if you're reading it from front to back, then you have to have the same letters in the same index of its opposite end. So like you couldn't have A B A B.
Right. And we could also have BA.
yeah, you could have BA, AB.
Yeah, you could have B A A B. But if it starts with an A, then you want to end with an A. So the other letters would be in the middle.
Okay, I like that, right? It's like it's mirrored, right? It's like we're folding it over. So if I
Yeah.
want to add a C, where do I go?
In the middle.
Okay, right. I'm still with you. So now if I want to add a D, where can it go?
Nowhere.
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 That's it.
And so how do we know that as a fact? How do we what's that rule? Why can I not add it?
Oh, can I tell
Oh,
you?
maybe can I? Oh, okay. Go, Brandon.
So it doesn't have the quantity of letters in the word. It doesn't have more than one odd number of letters. So if
Okay.
there's more than one odd number of odd more than I don't know how to like explain. If there's more than one odd quantity of letters in the word, then it's not a palindrome.
Okay.
Yeah.
I dig it.
Yeah.
Can we think about also a remainder?
Okay. Oh, sorry about that. Tell me more. What do you mean by remainder?
Like sometimes when we do a math calculation, something like the remainder is like one, we know there's only one extra if the remainder is like.
Okay, so we can. Okay, so Kong's thinking ahead here. He's saying we can use the remainder. So like we'll think modulo, right?
Yep.
To identify odd counts.
Yes.
Okay, I dig. So our rules. So per occurrence of letter, there can only be one odd occurrence. And we can use the remainder to identify odd counts. Okay, I'm totally on board. Are there any other rules that we should be taking account of? Or will this do it?
That's a good rule.
That's a good rule, Henry says. Okay. Anyone else think of a different rule that they want, or are we all happy with these rules?
I'm trying to think of like a second one because I feel like we still need one more, but I think that this one rule is okay.
Okay. So I think we're pretty good overall. So we've talked about, let's do steps to solve, right? So let's like think about what we're going to be doing. So our steps is make a counter object, right? So key will be, what will the keys be?
A letter.
Yep, right. A letter, character, slash, I'll say slash letter because different strokes, different folks, right? Value will be what?
Occurrence.
Occurrence.
Good number, yeah.
Occurrence.
Number of occurrences, yeah.
Caroline King says my screen is blurry. Is that true? Can everybody not see what's going on right now?
It's a little blurry.
Okay, I'll try like just not using for now then. Let's
Yeah,
like,
bro.
okay.
You should have known when you saw on the brand.
When I what?
You should have known when you saw.
When you said when you said I would have stepped away from the store and been like, nah, that's not for me.
Oh, it's still in beta. I think it's cool. It's just not, maybe it's not quite perfect yet. Okay, so you can all see it now better.
Yes.
Okay, you can see this screen, right? Like the screen. Okay,
Yeah.
great.
We got to try this on We Rise.
What?
And we should try this on We Rise.
Yeah, sure. On WeRise. What do you mean? Try this on WeRise.
Teach a whole lesson on We Rise.
Oh, you guys. Oh, yeah, sure. Yeah, that would be cool. They got to have recording functionality. So, if they've got that though, I'm totally game to go for it. They also have to. Can they share screens? WeRise. Oh yeah, cool. Oh, I'm really excited to check it out. Okay, I'm super excited to check out all of y'all's capstones. Okay, so our steps, right? We're gonna make a counter object. Key will be character, value will be occurrence, and this, we could think of this as a helper function, right? Whenever you're just doing a counter, it can be nice to make that a helper function. So then what's the next step to solve this? What would we be doing next?
Iterating through the object.
Yeah, right? We're gonna iterate. Oops. Iterate through the object. And what would we be checking for? What would we need to look for?
If there's more than one odd occurrence.
Right, iterate through object if more than one odd occurrence. Return false. And if we make it through the whole thing, what would that imply? After we finished iterating?
True.
Yeah. So if we make it through the whole object, it must be true. Okay, great. So we've got our inputs and outputs to practice. We've asked a bunch of clarifying questions. We've come up with some rules to help us solve it. We've talked about it. The time complexity. What would be our expected time complexity?
Factorial.
No. Factorial is if we would have done the permutations of everything. Based off of these steps, what would be our time complexity?
Linear,
Yeah.
because we're only looping through it once.
For in loop.
Linear. Excellent. And our space complexity, what would that be?
Constant.
Constant, because
No.
you're not mutating.
Because of what?
Nothing.
Why is it constant? Why would someone argue constant?
Is you're returning a Boolean?
So space complexity, actually, it doesn't matter what you're returning. It's about how much space you're using during the run of the function. So there's a couple different arguments that could be made here. There's an argument for O of n, depending on, because for every element in our string, we would have to create a new key value pair, potentially. And that's extra space. Does that make sense?
Yeah.
So for each character, we would create a new key value pair. Now, the other argument is constant, though, potentially. Someone could say O of 1 constant, but they have to be able to defend it. And the reason that this could potentially be constant, why is this not highlighting? Is because there's only 26 letters in the alphabet. So if we went through all the steps
Question.
and they told
Question.
us, just hang on.
Question.
Just-
Oh, okay, okay, okay.
So if we went through all the steps and asked all those clarifying questions and they told us it was always going to be a string, it was only going to contain characters from the English language, right? And that's what we that's what was determined. Then we could make the argument that it's constant because there is a constant number of letters. So if the string is 1,000 characters long, we know that it's only made up of those 26 letters, regardless of if it's 1,000, if it's 1,000,000, no matter the length of the string, it's the same 26 letters. So then it's just keeping track of that one letter and that number, and that never would have to change. So that's why that would be constant. Yeah, Henry, question.
You answered it because you said, assuming that it was just the English language.
Oh, okay.
I get it. Yeah.
Right, so because so there is a difference. So it's important to be able to talk about each one of those things. Okay?
Could you say the same thing for like if you were using numbers, because you only have like, you literally only have like 10 numbers that you can use from, like 0 to 9?
So are we talking about a string of numbers or?
Yeah, string of numbers.
Yeah, if it was just a string of numbers, right? Then sure, yeah. I mean, even if we determined that it was more than 26 letters, even if we just determined that it's always the same 250 characters, you could still make an argument for that being constant because it's never more than 250 characters, like of different characters, no matter what the length of the string is.
Okay.
If you were actually keeping track of like if this was an array filled with numbers and you were mapping those numbers, that would be definitely n, because we would have no way to control what the numbers could be. It could be 1,000, it could be 17. You know, if we're looking at it as actually a number. Remember, a string, a number that is a string is really a string. It's not really a number. I mean, there's weird JavaScript stuff, right? Like if I say 10 plus 1, right? We know that that's 101. But if I said minus string of 1, it becomes 100 magically. Like there's some weird JavaScript stuff, but a string really should be treated as a string. So the number, if I make a string of 56, right? That's just a string. That's not really the number 56.
Okay.
Cool. Okay. So let's build this out. So we're gonna first make our helper, counter, helper. Maybe there's already one that we've already built, but c'est la vie. It will just throw an error later, right? And so this takes in a string. We're gonna create our counter. So const counts, it's an object. We gotta iterate through the string. So for like character of string, because I don't care about the index. That's why I'm doing a for of loop here. And we can just check like, hey, counts dot includes. So if it has the character, let's just increment that count by 1. And maybe I'll switch it up to this today. Right, else, what would we want?
Equals 1?
Yeah, perfect, because it's the first time we've seen it. And then we would return our counts. So before we move on, we should check that this actually works, right? So let's try it. So we'll say console log counter helper, and we'll pass in ABBA, and we'll run it. So node, which file are we on? CD into maybe DSA. node warmups. Okay, so we get our A2, B2. So it's safe to say that it's working. For now, we're not going to worry about any capitalization or anything. We're just going to pretend it's a really clean string. And so let's write our function. Is permutation of palindrome. It's a long name, but it's clear what it does. And you use the is, right, to denote that this is going to be returning a Boolean. So it's going to take in our string. And we'll just follow our steps. Make a counter object. Okay, so let's just make our counts. So we'll say const counts. And we'll say counter helper, pass in our string. Okay, so now we have our object. Iterate through the object. If more than one odd occurrence, return false. So maybe we should have like an odd occurrence. So like let has odd, and we'll set this to false because we have not seen an odd yet. And then we can go ahead and iterate through that object. So what's the kind of loop we use to iterate through objects?
For in.
Perfect. So we'll say for let character in counts. Right? Remember, this is just key. I'm just calling it character because that's what the keys are. And then I'll say if we can just do our quick check. So if it has, okay, so first we got to check, we got to really do our rule, right? We have to make sure that per occurrence of letter, there can only be one. So we can use the remainder to check if it's an odd count. So let's go ahead and say if counts at character modulo, oops, I don't know why I keep not hitting that, modulo 2 is equal to 1. This means that it's an odd count, right? So if that's an odd count, we have to check if we've already have one or not. So if we already have one, if has odd, so if this is true, what do we want to do?
If we already have an odd, then we want to return false, right? Because like that, I mean, it's not a it's not a palindrome.
Exactly. So because if we already have the odd, we want to return false. Otherwise, this means that what we're hitting is the odd for the very first time. And so what would we want to do in that case?
Set has odd for to true.
Yeah, right? Sounds good. This is totally syntactically fine. If it's freaking you out too much, I'll just like do it. I'll be more explicit for now. And if we've made it all the way through, we said we were going to return true. Because we don't really care if we've had an odd or anything. We just care if we have a second odd. So let's go ahead and try that with our example inputs and outputs, which are over here. And so we will take this and we'll say console.log is permutation of a palindrome. We'll just do all of them at once. So we're expecting true, true, false. Let's see what kind of bugs we may have accidentally written in.
Oh, never mind.
Sorry?
Nothing, never mind.
All right. And we got true, true, false. All right, so let's just go through that again, right? We have our counter helper. This just creates an object, iterates through the string, checks to see if that character has already been included in the object. If it has, it increments the value by 1. Otherwise, it just sets the value to 1. And at the very end, it returns our counts. This is completely like we're not taking into account of capitalization or anything like that. If I wanted to do something like that, I might say like to lowercase here just to make everything that I'm sending in lowercase. Right. Also, again, we could do like if type of string does not equal string. We can write a little defensive programming here. Then we'll just throw an error. Input must be string. If we wanted to worry about spaces and all of that, we could add that into here. Like if we said like let avoid. So if we wanted to ignore all those things, we could make a new set that would take in a space. It would take in a question mark, a period, a comma, whatever you wanted. And then we would have to say something like, if avoid dot has character, just continue, which means like go to the next loop. I think that will work. Let's just check to see if I throw in an exclamation point here, if it still gives us back true. Yeah. So just depends on how you want it to be written, right? And whatever you decide with your interviewer. But now this is relatively protective. Okay, so we've protected to see, make sure that we're actually getting a string. We've got our object, key value pairs. We have a variable to keep track if we've seen an odd yet, what we're calling has odd. We're iterating through our counts. We are taking the count, modding it by 2 and seeing if it's 1, because if it is 1, we know we have an odd. If it's not odd, we don't care. We know evens are fine. We can have as many evens as we want in a palindrome. That was something we determined earlier when we were looking at the different types of rules. We only were worried about odds. And then when in the event that we have an odd, we have to check if we already had an odd, we want to return false. Otherwise, we want to go ahead and say we now have one odd. So if we see another, we'll return false. If we make it all the way through, we return true. Any questions?
Can you just scroll back up to the avoid?
Sure.
Yeah.
Right, so this is just a set of things to avoid so that we can have a constant lookup. I could do it as a string and do includes, but then I'm like iterating through that every single time. I'd rather just have an immediate lookup. And so this is just checking if we want to avoid this character. Right, that doesn't necessarily mean that this is the right solution for everybody. This just means that it completely depends on your interviewer and what they want and how they want special characters to be handled and case sensitivity. And those are all things to make sure you ask about. Every time you get a string question, you can always pretty much ask the same type of questions. So just memorize them. Think about them every time. They're all pretty much the same. Any other questions?
So the in the count in the is permutation of palindrome function. The line 287.
Yes.
So going from 286, we're determining if there is an odd key value.
Yep.
Then we're saying if it has an odd, return false, else set it to true.
Right. Because when we start off, we've never had an odd. Once we see an odd, we want to either set that to true, or if we've already seen an odd before, we can go ahead and well,
Okay.
good question.
So my thing is, how do we know if we've seen an odd? Is that line 286? How do we know that
280.
has odd is now true?
Well, we don't know. That's why we're checking. We're saying if we've had an odd, has odd. So this can only be set to true if we've already seen an odd. So if we've have one, we go ahead and return false.
Okay, gotcha. I get it now.
Awesome. Awesome.
That's kind of like the counts. Like if we've seen one, plus one. If not, then add one. Then add it.
Yeah, exactly. Yeah. So if we've already seen one, we're just returning false. Otherwise, we're going ahead and saying, well, we do have an odd.
Okay.
Cool. That's good clarifying. Thank you. Any other questions on this one at all? Okie dokie. I'll, of course, push the code. Let's stop the recording.